Thank you for having me.
Pasha, welcome.
Thank you.
I thought that we had clicker somewhere. Do we still have clicker?
Oh.
Yeah. Here we go.
Thank you.
Yes.
Let's. Oh, it works.
Nice.
Nice.
Quickly.
So, you probably know the name of the talk, so I won't read it for you. I am Pasha. And this is my actual story. I didn't invent it especially for this talk. It's like what happened to me in my life. Who uses ChatGPT, Claude, and so on here? Who understands how it works?
Why are you confessing?
Because I don't. The whole talk is about I do not understand, me not understanding how they actually work. And I actually didn't care about how they work at all. Like, somehow, magical box, black box, I put something in it, it gives me an answer. I'm kind of happy. When I say really, it's a slight exaggeration. Of course, I'm curious, I'm a developer advocate. I should be more or less curious about things, but they're just so complicated. But anyways, I didn't need to know much about LLMs and different neural networks. Of course, I didn't hear about RAG, whatever you call it, and I still can't remember how it's separate. Retrieval-Augmented Generation. Yeah, right. Who's like me here? Who didn't care? Who doesn't really care how they work? Alright. I'm in minority. That's fine. Well, so I will try to cross some T's here. It doesn't mean that I will explain to you how ChatGPT works. Again, I don't know, but I know how some things work, and I know how to solve some tasks. So, of course I heard about neural networks. This is what I heard about them. Who saw this picture or any picture like this? Yeah. So,
The baseline. That's the baseline.
Yes, this picture is a baseline. If you heard about it, you are good. I mean, if you saw it, sorry, you can't hear about the picture, I guess. But, so what I see in this picture is this. Like, there is me, there is black box, and there is output. And it kind of reminds the scheme below. There is me on this orange layer. Then there is black box on green layers. I don't know what's happening there. And then there is output on the red layer. I don't know why they're orange, green, and red. Again, it's a black box. But now it's probably time to tell a couple of words about me. I've worked with JVM languages for a relatively long time, since 2009, I think, or maybe 2008. I used to be a backend developer, QA engineer, data engineer, engineering manager, I mean, all kinds of stuff. I like my data, actually. I even wrote Kotlin API for Pasha Spark, just because I could, and it was an interesting task. I worked with data scientists a lot when I was a data engineer. Never understood a word of what they're saying, like, I mean, at all. It was maximal flow, what? Product managers and so on. I usually did some performance optimizations. This part I love. So premature optimization is the root of all evil, right? This is what I do, premature optimization. I see this code, I'm trying to improve it. I don't care if anybody needs this improvement. Do not be like me in this. I mean, it widens your horizons. Nobody will care. And of course I worked with Spring or without it. Most part of my development life with Spring, but there were dark times too. I'm also a developer advocate at Bellsoft. It means that I should be curious, I probably should be giving talks, I should experiment a lot. I should like programming, and I like programming. I mean, you probably cannot stop me from coding. I guess there are people here who come home and they are just trying to not turn on their devices, computer and so on, to not write any code. I'm the person who, well, I don't have any office, I work at home, so every time when I'm at home, I'm trying to write some code. Even when my management tells me, Pasha, we need to write this blog post, I'm writing code and procrastinating writing an actual blog post. I need to write blog posts because I need to produce content, and this talk is this kind of content. But yeah, by the way, you can follow me, Blue Sky, Twitter, Mastodon, whatever you use. And yeah, to produce content, I need to understand what we are doing. We are Bellsoft, as you can see on my t-shirt, and we have our own GTK distribution. It's called Liberica GTK. So I kind of know what GTK is, but if you ask me about one specific aspect, any of them actually, I will probably drown. Like, if you ask me, Pasha, what is CDS, class data sharing? I will tell you like very shallow information about CDS, and then I will tell, now I need to ask my engineers about it to get deep knowledge. To solve this issue, we actually have a lot of content on our site, blog posts, documentation, white papers we write, and so on. I just cannot find my way through them, because there are a lot, hundreds of blog posts, probably hundreds of documentation pages, at least 50 white papers we wrote. This is crazy. I mean, I don't know who are the people who can do it. So, since I cannot do it manually, I decided to do, well, what all the yak shavers do, to look for solutions. First, I was thinking about Elasticsearch. Probably I should put all our data inside Elasticsearch and just query Elasticsearch. Like, Elasticsearch, at least find me CDS. Like, well, what CDS is. I mean, probably it will return me some documents, something like that. The second idea was Google Desktop. Who remembers Google Desktop? Two of you. By the way, during preparation of this talk, I discovered that Google Desktop is no more. It's dead. Like, you both folks, both guys here who know Google Desktop probably need the three of them, probably need their pain medications for their backs. Yeah, that's why Google Desktop is already there. I can also use good old grep, right? Well, not, because there are typos and you can grep in PDF file. I think usually you can't. So there is this memo, who are we developers, what should we do, solve problems, what will we do, yak shaving. That's what I do. So like, I could probably use some existing solution, but I was like, part of my work is to experiment on things, so probably I should just write my own solution.
Are you sure about shaving?
I'm not yak, so we shouldn't shave me. I'm shaving yaks. They just cannot answer. So the obvious solution is, we have all these ChatGPTs, Claudes, I don't know, DeepSeeks, and so on, so on. I probably need AI to answer my questions, right? Like AI that will actually take my whole data, all these blog posts, white papers, and so on, and will answer questions. But how? I do not know anything about ChatGPT and so on. Luckily, I have a friend. I know it's hard to believe. Like, I'm nerd. Usually they don't have friends, but I have one. I'm lucky. And I'm even more lucky because he was ready to answer my questions. I didn't hear anything from him for like 2 months, so probably we are not friends anymore, I don't know. I'm not very good with the social stuff. What did I ask? How do I search through my documents? You do this neural network magic for years, right? It's literally what I asked. He's a good friend, so he didn't send me somewhere. But he asked me another question. What do I already know? And I said, well, I heard about Word2Vec, I heard about layers, you remember the picture, right? Black box and so on. Embeddings. He was, okay, he said, then explain me embeddings. And I was, I don't know what embedding is actually. At least I didn't know at this moment. So
Going to bed.
Hmm?
Going to bed.
Yeah. So I actually had to Google for it, and here's an example of embedding which doesn't make any sense. Like just a random array of doubles, some of them positive, some of them are negative. And there is another embedding here. I am not sure what embedding is. What do they mean? So actually, embeddings, when you Google careful enough, you find that embeddings is a way to represent your data somehow in doubles. For example, if we need to encode very simple entities, like cities, centers of the cities, we can say that we can describe any center of any city with embedding of size 2. It's just 2 doubles. Where New York is located, where, forgot. Coordinates, yeah, coordinates. We can just use coordinates as our embeddings. This is a perfectly correct example. The only issue is just, it's a little bit unrealistic. Like, usually we need to encode much more complicated data. And if we would try to describe cat or dog as ideas in coordinates, we would probably struggle. But similar things should have similar coordinates. For example, cat and kitten, they're very, very close to each other. And similar is a complicated term. We will talk about it a little bit later. Cat and rocket, on the other hand, are very different, like New York and Tokyo. And they will have very different coordinates for embeddings. I have a small video here. Imagine we have an idea of king, an idea of man. They're actually vectors. And we can add them to each other, and then we can add king plus man, and we also have another idea of woman. And when we do king plus man, king minus man plus woman, we actually get queen. And queen equals, sorry, the animation is slightly sloppy. King minus man plus woman equals queen, and the whole thing can be somehow represented as number vectors, because you just saw. Yeah, too late. Okay. You can just hit on this in the middle of the screen. Yeah, they're just vectors. King is just a point in space. In real world, it will be like in modern neural networks, it will be probably 1,861 dimensions, not 2 like here, but this way it's just easier to visualize. And we can do all these simple vector operations and say that this is how terms are related to each other. Obviously, they do not make any sense here. It's just king minus man plus woman equals queen. I know this is like gender charged thing, so if you have a better example, please tell me, I will change it. But so far, well, it works, kinda. I will not answer that.
Basically, the distance between man and king would be almost the same between woman and queen.
Yes, that's true. The distance between king and queen will be the same as distance between man and woman.
Yeah, that's how
but
we
what?
capture the meaning.
Yeah, but what I like about it, that we can actually create relation of any term to any other. So even if they're completely disconnected from each other, like T and door, they're very different. But for neural networks, they still have some relations. They're still just vectors, and you can deduce one from another or add one to another and see their relation and build something from their relation. If you are better in reading text than watching videos, here is essentially the same. Father minus man plus woman equals mother. Again, I know, questionable, but I mean, there are multiple personality traits which make someone a parent, and it's not only about gender, honestly.
You won't understand it.
Yeah. Yeah, but idea is essentially the same. And there was a huge breakout when Google introduced Word2Vec. It was the first interesting neural network which allowed relatively fast to find relations between any terms. How it works? It predicts which words can appear next to each other. For example, you can usually see cat next to pet, and Word2Vec will notice it, and it will put them closer than, for example, cat and sun. So cat and dog often appear near what's like pet, food, and vet. It means that their vectors somehow will be closer than with other words. Word2Vec introduced several key innovations. It was very fast to train. You just feed it with books almost with the speed of light, and it gives you immediate results. And it produces actually very high quality embeddings. At least at the time when it was embedded, Word2Vec was relatively small and at the same time very efficient. And they also show that very simple neural networks can actually catch up very complex meanings. Before that, linguists tried to create very huge semantic networks to explain that these should be close to these and that, but they were significantly worse than any machine, actually. They're just slow. And they're trying to be smart, and eventually it's very hard to outsmart a machine when we are talking about statistics. Word2Vec has a huge impact. It's almost not used these days, but it still gave us significant results. First of all, result of Word2Vec work is that each word becomes dense vector. It means there are no huge arrays of zeros inside this vector. Similar words have similar vectors, and vector math, as we saw on the video, captures semantic relationships, which is very important. Vectors back then were relatively small, 100 to 300 dimensions. Still, I mean, it's very hard to imagine, right? For me, it's almost impossible to imagine how can we say that, I don't know, doll has 100 dimensions, or 1,000 dimensions for that matter. Neural networks for me are still magical. I do not know how they do it. It's just very impressive. I know that there is some statistics, some frequency analysis. Yeah.
Okay. Does this mean that the computation of a vector is based on how large your data set is? So if it grows larger than one computation of new word, for instance, pet, it would take
yes.
longer
The bigger your training set is, the more precise your result of computation. I cannot really say precise. It's not completely honest because I cannot measure the precision. They say they think that it's more or less precise, and it's very important that cat should be like kitten but shouldn't be like dog. And the more data we feed it, the more statistics it will get.
Does it need recomputation? For instance, you calculate that the vector of cat is this, then you calculate pet, then is this, but you calculate another word, and then maybe you need to shift cat and pet.
Essentially, it's just a huge equation. The whole model is just a huge equation. It doesn't actually know anything about cats and kittens and dogs and rockets. It just gets a random input, puts this random into this huge equation with different weights between before each variable, and gives you the result. It might look nonsensical. For me, it's still nonsensical, but it somehow works.
It looks sensical, or whatever it's called, when you have already something computed, but the first thing to compute, I cannot understand.
You do not need to actually compute. You do not need to know any words of any meanings of words. You only need to know how close each words are to each other in your source text.
And the first one, how you put the vector of the first word? Where do you put it? So
it creates it by itself magically. It's still kind of black box. So what you are asking is, Pasha, how the first word, it becomes a vector. But I think that actually it's not important. The only thing important is
they use randoms.
what? Random?
When the model not trained, they use the random way.
Yeah, so
They train it, so
it means that it's not important what is the first vector, because all the next vectors should be close or far away to this vector, right?
yeah, during the process of training, they are close to each other and so on. So it depends on the data.
Thank you for the question. Let's move on. There are multiple limitations of Waterback. Current, I don't know, ChatGPT, Cloud, and so on, current LLMs can work with huge texts, actually. Waterback can work only with one word. And it cannot handle polysemy. It's when, I don't know, like when the same word has different meanings, it's a huge issue for Waterback. I am sure you have these examples in Bulgarian language, and I know them in Russian when, I don't know, you have the same word with completely different meanings.
Right.
Hmm?
Right. Once again, my
Right, you kinda, yeah, right. And it also requires pre-trained embeddings for each word. And it's essentially, it was superseded by better models or larger models like BERT, and well, modern models can handle multiple word namings in absolutely the same method. The same way. They take the piece of text and they say, this piece of text has this vector, and now we can compare it to all the other vectors we have. So instead of cat, 0.1, 0.2, minus 0.3, and so on, we get the cat set on the mat, 0.4, minus 0.2, 0.1, and so on. It's not really different in any way. Captures meanings of entire passages, and similar texts get similar vectors. And yeah, obviously, this is what we will use in our example. We need to handle pieces of text somehow. How will we work for them? How text embeddings work? They split text into tokens. They are usually words, but depends on the language and so on. For each token, they do some processing, and then they merge results of processing of each token. Kinda obvious. I actually didn't think about it when I started, but then it became more or less transparent. Yeah, you can't really give the whole vector to the whole text, but you can understand every single word in this text, and then create, like, I don't know, a mean vector of them. And then they combine token representations, see, and output fixed size vectors. Fixed size vectors are kind of important. It means that our vectors are always of the same. No, arity. Yeah, arity. Because it makes them very comfortable to compare. And there are multiple models like OpenAI's text embedding SADA, sentence BERT, universal sentence encoder, and so on. Why do we care about embeddings at all? Yeah, it's kind of fundamental knowledge, which I didn't have to understand how to solve my task. Again, my task is to process a lot of documents and somehow get answers for them. Now I know that I should somehow create embeddings from my documents and then work with them. It's essentially the same, but now it's that now is the time to tell about RAG. RAG workflow is very simple. We convert all the documents to embeddings. Sometimes the whole document doesn't fit the context window, so then we split the text and we feed it into our model. Then we convert user query to embedding. This is a very interesting part. I have never really thought about it. That when I come to ChatGPT and ask ChatGPT, give me the perfect recipe of, I don't know, bread, it actually converts what I ask to an embedding. And then it looks in its database. Result could be beer, but bread is very different from beer. Should be. Probably not in Bulgaria, I don't know, but in Germany, bread is like a completely separate culture, which is also very important. liquid, no, bread is the hard beer. So then for RAG we should find in our database the most relevant documents, and the most relevant means the similarity is very high. And then we should feed the relevant documents into our prompt to our AI, whatever, AI systems. So in a way, embeddings are not only a way to search, and RAG is not only a way to search, it's a way to summarize documents, because suddenly the huge text becomes a relatively small array of doubles, or floats probably. The thing I couldn't understand is why can't we just put all the data we need to process inside some database and force the neural network to go to this to go to this database and ask it, like, it's there, data is there. What I didn't really understand is that neural network is not a program. Neural network is a relatively dumb data structure. It doesn't have any logics. It has a lot of weights and huge equation. Equation cannot go to database. It doesn't know what database is. It only knows how to convert how to convert input to output. And yeah, essentially it's a huge bunch of hard-coded weights. Hard-coded is slightly incorrect, obviously, because there is no people who sit and type perfect weights for each variable in the neural network.
Aren't there like a billion Indians that are doing this?
Yes, there is a version that there are like a million Indians who sit and do it. And I cannot say that it's unreasonable. My wife still thinks that it's how it works. Maybe she's right. But what they say, they have smart machine which can run different weights very fast until they will find
2 billion Indians.
maybe. And until they will find a relatively good combination of these weights to these variables. And yeah, neural networks can't access anything directly. So, the essential idea of RAG is to mix relevant data in the prompt and make LLM think about this particular prompt when it has all the relevant information, or a lot of relevant information. So how do we implement it? First, we can convert documents to embeddings, store them in a vector database, convert user queries to embeddings, find most similar documents, document embeddings, and filter relevant documents to LLMs. Not all documents can be converted to embeddings directly. There are a lot of limitations, and they are very different for each vendor, and obviously on your they depend on your particular model. How do we find similar things? There are many ways to define what is a similar vector. For those of you who is better than me in math, I have a bunch of LaTeX here, which I do not really understand. And I didn't understand it, so when you can understand something, you should create a video. The same math, cosine distance between something. Now it slowly should go down. Yes, thank you. Yeah, like that. And then we have three very different words: rose, sunflower, and sun. And sunflower is visually closer to rose than to sun, even though it has sun in its name. And then we just measure angles between these vectors. In multidimensional space, it's almost the same. And then we essentially calculate the cosinus, and this is our result. Smaller cosine distances means more similar meanings. This is how we know from our neural networks that roses are closer to sunflowers than sunflowers are to the sun, even though some of them are relatively close. There are multiple databases where we can store our vectors: ChromaDB, Viv8, Pinecone, Milvus, pgvector. Pgvector is just a PostgreSQL extension, so if you already use PostgreSQL in your project, and you probably do because always everyone does, then you can just add one extension and have a lot of things solved for you. This is for those of you who is not good in reading text, I have the same process in diagram. Administrator puts document to OpenAI. OpenAI returns embedding, and then administrator saves embedding plus source text in vector database. Then the same happens to query, but we do not put it into the database. And then we can use our vector database to ask it questions like, find me the n most relevant documents there. And we also can say which algorithm it should use. Probably it's cosine distance for whatever reason it's the most popular. Probably, even though it's relatively expensive, but Postgres is very good optimized and I like it.
There is a new version of the time scale, which basically optimized only for the
There is a new version of timescale, they say, which is optimized for what?
vector databases.
For vector
Yes,
databases.
exactly, it's kind of new.
I mean, these days everyone does vector databases because RAG is a huge thing, and everyone wants cheap full text search with typo support and so on. So there is a database which is called, how it's called, Mail Search. I have completely different set of materials on it, where you can save just documents. It will create embeddings automatically. It will perform very nice full text search for you. And this is how the whole thing works. User makes query to backend asks LLM, gives LLM this query, LLM returns embedding, then backend asks vector database to give it top K, the most relevant documents, database returns relevant documents, backend sends query plus relevant documents to LLM, LLM returns answer, and backend returns answer to the end user. This is what we should see in a demo. Now, sorry, it will be a little bit weird because I have my demo here. You won't be able to see me. Probably you don't need to. I'm not that beautiful. So, this is the code readable?
No. No. Is that Java?
It's Kotlin. Who cares?
That's okay.
But okay, I will ask differently. Shall we make the code bigger?
Yes.
Gotcha.
It's still gonna be unreadable.
Because it's Kotlin, but has a big one.
It's not that important. I mean, I will try to explain everything. So, you probably know the annotation REST controller. Who knows the annotation REST controller in Spring? Almost everyone. This is just a REST controller that has two dependencies on vector store. I like that Spring AI tells us you shouldn't care about your vector store in your code. We kind of have it. And then they abstract everything away from you. Like, if you use Milvus, that's fine. If you use pgvector, that's fine also. Not important. You also have chat model, from which you can create chat client. And you don't need to actually read Kotlin to understand that we create chat client from chat model. I also have my own thing called unstructured client. It's a huge piece of code in Kotlin, which does only one thing. It sends a document to a service called unstructured.io with its API, with a lot of potential parameters. I don't even know. The API is very simple. Just give us 30 parameters and we will give you correct answers.
Just answer the question.
Yes. And then it returns something. Returns something.
Even in Kotlin it's readable.
It shouldn't be. I already wrote it for you. You shouldn't read it. You should understand that there is a service. They have Java, they have Python SDK, they don't have Java SDK. For Java they say, just use HTTP client. That's what I did. So, when an administrator wants to store a document in my Postgres pgvector database, vector database, whichever I use, I do a very simple thing. I say unstructured client dot request. I put file there. I say that if the resulting documents are too small, under 500 characters, they should be joined to 500 characters, and that there is maximum of 8,191 characters in the document. Because this is the limitation of OpenAI, don't ask me. This is oddly specific number.
This is hardcoded.
Yes. I mean, where did this one char? I could understand 8,192. Why is it 91?
-1.
Yeah. Why? I get it that it's -1. Why?
Trailing zero.
It's a binary number. Full with ones.
Wait, it shouldn't be.
It is.
Okay.
It's a binary number. It's only once.
Okay. It asks me if we should include original elements, which is like if it parses HTML for me, which is the case for blogs, for example, then I do not really want to preserve all the HTML text. I only care about the text. And there are multiple chunking strategies. I was too lazy to create a noun with it. But this is what you should do probably. But I only need one strategy. It's basic, which is essentially just do it. Don't do any smart transformation on my text. Then something interesting happens. I have these responses, which is unstructured responses from unstructured client, and I need to convert them to responses to documents that can be understood with OpenAI. They have their own understanding of what is a document. So I have this class with very simple name, unstructured response document adapter, that is inherited from document, and document is an entity from Spring AI. If you look at it, we see that my machine crashed several days ago, and I don't have source code downloaded. Sorry. Let's try it. No luck. Anyways, document has a bunch of data, including ID, metadata. Metadata is just a map of string to anything. Content, this is important part. Media is not that interesting, and embedding. We were talking about embedding for a long time, for like half an hour. So you probably can imagine that this is the most interesting part. But content is also interesting because we, like humans, work not with embeddings. We cannot read these vectors. We can only read texts. Not only, but mostly. I also have my own implementation of toString here, but it's not interesting at all. Let's get back. Please. Then I say vector store.add documents. And this is once again just another abstraction which Spring does for me. It allows me not to think what actually happens when I add documents to vector store. What actually happens underneath is every document, every small document of size not more than 8,191 character being sent to a neural network, it returns embeddings, and then Spring transparently saves both embedding and the source text inside the database. And then we say that we are all right, we are okay. Just empty response, because I don't care, it shouldn't be a beautiful API to save documents, for internal usage at least. The second function we have in our controller is search, because it's, again, just to remind you, this is what I was caring about. I needed to look up my data in our documents. I needed to search. So, first thing we do, we create a query, search request.query with top key 3. Who understands what's going on here? Yes, I'm asking because I'm not sure if it's transparent or not. So, in Spring AI, the search request is just another abstraction that allows us to create abstract requests, which abstract queries with n or k most relevant documents. Underneath, depending on our database, it will convert this top k to actual SQL or actual language of this database, whatever it is. Then we say vector store.similarity search query. Because when we created query, it was just abstract query. Here it's actually executed. And then we start doing very dumb thing. We say, okay, now when I have all my 3 most relevant documents, I want to join them to string with this weird separator, just for it not to mix with anything in my text. And each of them will be converted to form title, and title will be a file name, and body will be, and file name is just a part of metadata, as you can see, and body is obviously just a document that our database returned. Then I create a system prompt template. This is what you usually see in templates. I don't know why we should speak to neural networks, to ChatGPT and so on, like they're idiots. You are a helpful assistant. I mean, for me, it's like a default. They should be helpful assistants, but somehow we should still write it. Otherwise, results will be worse. Really, I mean, you can check. I performed an experiment. I removed this phrase, and the answers immediately got worse. You find information in data provided below. This is kind of non-obvious. Yeah, we should say it. The format of data. Then I describe the format of data. If you have to reference a document, this is just like I used to talk to my developers. Just explain the task, what they should do, and they will do it. You usually don't need to explain them how they should do it. I'm happy about it. And also, if there is no information in provided data, say, sorry, I do not have such information, and goodbye. Because it's me, the user. I do not need any of these LLM hallucinations. Then I just have this template for information. Somehow Spring AI came, they have this idea that they have their own templates and language for conversations with AI. I'm not sure why it is this way. Why can't we use something else? But anyways, we have this system prompt template and we can create a message from it. And we just put one thing here where there is template information. We actually put our information. I don't know, I think with Kotlin I could just inline it in there, just reference the variable, but somehow this is what they recommend. And with usage, and this is a system prompt. So this is what we tell as administrator to our neural network. And then there is a user which actually asks the question. It's even more interesting. So we create very simple user message from template, which contains like this template question. It's in triple double quotes. It's in 6 quotes. Because, yeah, it's in 6 quotes from each side. 12 quotes, right? Sorry, as I said, I don't have any technical background. I'm not good with this stuff.
Looks like one is a template.
Yes, absolutely.
And then the other one is the question.
The question is the question should be enclosed in double quotes. That's why we escape it. And then we create model, which is just question to queue. We create user message, where we say user message template create from model. Get content, then we create prompt, then we say chat client, thing we created way before, somewhere here from chat client. Prompt, call content. Prompt, it means that we pass prompt to it. Come on, sorry. Prompt, we pass prompt to it, then we call it, and we are not really interested in anything in returns but the content itself. And then we return a response to our user. You just saw how in like what 5 classes and a huge bunch of properties, please. I mean, not in price huge, but again, it's a project with 5 classes. It shouldn't be big. Properties should be simple. But we have a lot of descriptions here. We say that our vector store is PG vector. This is nice that we can say, because who knows, maybe our vector store is one in production and another on user machine. Totally possible that we use PG vector on user machines, and in our production we use some cloud service or whatever. Index type, don't ask me. I cannot decipher HNSW for you, I just do not remember. But they say that this is an index type you should really use, because it doesn't require any pre-training. Then we say this is our distance type, how we measure the similarity between our vectors and its cosine distance. You already saw a nice video about it. This is how many dimensions we will have in our vector. It's actually very interesting. When we use PG vector, we can't have more than 1,536 dimensions. Again, the number is totally specific. I can't understand. But luckily,
3 times 512. 3 times 512.
I didn't understand, sorry.
3 times 512.
Why? Yeah, so only specific. 3 times 512 is very nice mathematical answer. It doesn't really make any sense.
It's like 42.
Yeah, it's like 42. Yeah, somehow. Probably, I don't know.
It's a power of 2. Yeah.
What?
Some power of 2. Yeah.
Well, everything is some power of 2.
Yes.
It's not a whole number power of 2. Everything? Is everything some power of 2? No, negative numbers, no. Negative numbers are not. Yes. So, we use OpenAI to create embeddings for us. We can pass API key here. I just put, what is it, template here. I say that chat should be enabled and embedding should be enabled. It means that we create both embeddings and ask questions our chat. Then I say that here is how you connect to my PG vector. It's PostgreSQL. You probably all know this stuff.
Very strong password.
Hmm?
Very strong.
Yes, because this is what I use on my machine. I mean, why not?
It's very
Absolutely. So I hope, please do not do it in production. Please do it on your machines. It's so much simpler to use simple passwords on your machines when your Postgres is not open to everything else. And I have a couple of custom things. Unstructured key and unstructured endpoint. Can I? Fuck, it's hard to do with one hand. I can. As you can guess, one of 5 classes I have is configuration properties or unstructured config. So when I say that it's a small project, I really tell you the truth. We are way out of our timing. So I'm not sure if you want to go through the whole struggle of creating an HTML document and uploading it and then querying it. You can just trust me that it works. I mean, because there is nothing to not work. We call unstructured. It returns us responses. We convert them to documents, save them inside our vector store, and that's all.
There is something that
Hmm?
there is on Spring, so there is something that might not work.
Yeah. Well, we can try. Who wants to try?
No.
Who? Okay, like 2 people. Sorry, you're a minority. Then we are switching back to my demo.
No. Show it.
We can, after the talk, you can come to me and I will show you.
Person.
And then 6 hours later.
Probably. So, summary. Every talk should have summary. RAG is very simple when you don't need to think about how neural networks really work. Please implement it in your products if you need to search over random set of data. It's very, very comfortable. But you need to know embeddings to use RAG, because otherwise you are doing things blindly At least you should understand this basics I told you. It's vector, we have ways to compare similarity of these vectors and so on. Embeddings are not magic. They were magic for me when I asked my friend how to implement this. But essentially, it's just an array of doubles. And you don't need to know how LLMs work to implement your own drug. And this is a very good place to be. Because they have hundreds of engineers just because they know how LLMs actually work. We don't need to be there. You can ask questions, Twitter, Mastodon, again, whatever. I have a blog post on this topic, and also you can find the whole source code on my GitHub. You can, yeah. And Mitya will give you QR codes for the presentations. Thank you so much. Questions?
Yeah.
So retrieval part is basically semantic search. It's the most challenging part in this task. So how do you measure quality?
With my satisfaction. I measure quality with my satisfaction. If I am satisfied with the results it gave me, this is cool. If I'm not satisfied, I should do something different.
So you just run a few examples, and if you
yeah, there is a huge issue of, in general, estimating of quality of search. When you work at Google or any big search engine, they have this issue. We have this search engine result page. How do we measure if results are relevant? Well,
we use MRR. This is a metric from recommendation.
Which
system.
is
basically we show the k best numbers, best results, and measure. We see what's the rank,
what's the
rank, the
rank?
position,
Yeah.
the position for the results we expect, and then we calculate the results for the multiple.
How do we know which results we are expecting? On a closed data set, it's relatively simple. We just know our answers. In open data set is Google, it doesn't really work this way because anything can suddenly become closer.
You mentioned you split the documents into chunk.
Yeah.
You can use the chunks to get the next chunk.
Yeah, so I can measure the quality here, I think the same way. I know my documents, I essentially know my documents and I know if they're relevant or not.
Yeah.
I still don't know how to turn it to production quality testing because I don't know how will it behave on the next blog post I upload there.
You'll never know.
Yeah, this is my issue. I kinda trust the system. I kinda trust that assigned distance is simple metric that will just work.
The science system is simple things, but the retrieval is much bigger and complex
Yes.
systems. So you need to transform text, or use different models, etc., etc. And you need to measure the quality.
Yeah, I also can't predict even what happens if I switch models. So I essentially tested with one model, and it's just my satisfaction with my limited data set.
Okay.
Thank you for the question.
They call that the vibe test.
Yeah. Please.
A bit old question, but have you tried or thought of downloading an LLM model locally and trying to?
It works. I just do not have a machine with nice GPU, so it works very slow.
Yeah.
So I installed Llama on one of our lab servers, 64 CPU threads and so on. It gave me my first answer in like 3 minutes. I was like, it's a little bit slow. I could probably find it faster another way. So I switched to ChatGPT, but OpenAI has very nice integration with Llama.
Yeah, I guess because there's some controversy about OpenAI leaking.
Yeah, absolutely. So if you have a nice machine, just do it. And if it works for you, just do it. Because why not? Answering questions when you already found like 5 relevant documents is a relatively simple task. they all should handle it more or less okay-ish. Again, I cannot swear that it will work, but it should work, right? I suppose. And Spring AI has integration with all of them.
Yeah, and one other question: do you actually need the LLM model to do the vectoring, or is it plain math?
LLM model is plain math. Yes, I need, because well, you can tell that I cannot sit and write a vector for each term. They're just better in it than me, and I don't know, probably my machine hints about something. Yeah, and I don't know how to do it without LLMs effectively. They have special models, relatively small models, to create embeddings for you, all of them. Mistral, embeddings, ADA, and so on. I actually don't know if DeepSeek has a model to create embeddings. Probably they do. No,
Yeah,
but-
They should. Yeah, different model will give different weight.
Yes.
Different
Yeah, but it's not that important.
It
It's not that important because we still can compare them to each other. See, it's not important what particular vector for a particular term is. We just shouldn't compare embeddings created by different models because they're different. Yeah, their starting points were very different.
So my question was exactly like this. So if you want to change the LLM model, that means you need to educate your
Yes.
RAC.
Yes, I actually did it like 5 times when I prepared the whole thing. I tried different models.
What is your electricity bill?
Hmm?
The price.
My next.
No,
Electricity bill.
He calls the model in the
Ask
cloud.
Bellsoft. They are paying for my machines.
Did you compare the size of documents and the size of the vector database?
Oh, they're not related. Size of document does not affect the size of embedding because they all return embeddings of the same size, whatever it is. It's usually 1,000 whatever. This 1,563.
36.
No, 36.
In German 63, but in English 36.
Yes.
Thank you. And this is a very important aspect again, that the vector is always of the same size from one model. Did I answer?
I have another question. Maybe you know that one of the biggest drawback in RAG system is the not ability to work in enterprise, in with big data. You have many issues with hallucinations, something like this. It's very nice for local solution, for the local company, but if you work with big data, terabytes,
Well, at some point you should become a Google or another big search engine. They have a solution for it, it's just not RAG. But, for example, Perplexity.ai essentially does that. They use search engine to find relevant documents, then they read these documents, and then they answer the question about the documents. So, what's big data actually? Terabytes?
terabyte data.
Well,
It's not.
It depends on.
yeah, so now we will have a religious war, what is big data and what's not. I knew that it happens. Yeah, what I can see, if you have terabytes of data, it just won't fit our PG vector. The issue is not with hallucinations.
It's with the vector database.
Yes, we will hit the issues with vector database, and I don't know how to solve it.
Change the database.
Change the database. Use Google Spanner. It's very, very cheap for this task. Sorry, I'm being ironic. Yeah, there is one more question.
I have a stupid and probably shallow question, or vice versa. So, if I understood correctly, you ask the model to give you embeddings, then you start something in your vector DB, then you still send the prompt to the model. What is the whole point of it? Can't you just send the because you asked one other service to make your document into some text or something like that.
Yeah.
So can you just send text or chunks or whatever to the model and ask the model?
This is what I eventually do. The question is which pieces of text do I send?
Yeah, context.
So I
Otherwise-
can't send all the
Very
text I
big
have.
window.
Because all the text I have is just too big for the context window of the model.
Yes.
I should find relevant pieces of the text.
So you need to do this kind of
Yes,
work.
and this is why I have to use my whatever I use vector database to find relevant pieces, and it will be the context where my model works.
Yeah. Okay. That was my question. Thank you.
More questions? Thank
Are
you.
those services free for the services that you use?
No, it's not free. But I use it for free because they allow to be. Dotsoft doesn't pay.
It's a
But I have a friend
microtransaction
there.
game for nerds.
She works as a developer advocate there.
Yes,
And I
it's
don't
called point shooting.
Yeah. I don't have, Masha, I want to give talk, but I want to use your product. Can you please give me a key for the product? And she said, you have it.
Have you tried with different compare functions like I see?
Talk to Mike, please.
Cosine. Have you tried with different functions?
Did I try different algorithms
Yes.
of similarity search? I
Coming
tried.
back coming back to the first question is how you assess whether one.
I tried,
result is
but
better
on my
than
data set, I do not see any difference. It's just, it seems it's too small. I don't see any difference between so I use what is like default in Spring. The default in Spring is cosine distance. Again, it's relatively fast thing, not blazingly fast, but relatively fast. More questions?
By the way, Anthropic just released some. Yeah, Anthropic just released some prompt engineering guides again. They said if you put like the huge chunk of text at the top and then your instructions in the bottom, they measure like a 30% improvement. So this is not a question.
Yes, I can believe that. I'm not a real prompt engineer.
Which model?
Hmm? Yeah, since it's Anthropic,
Yeah, it's
we
called
can,
Anthropic,
we can think that it's either Haiku or Sonnet.
Yeah, but I think that can work for most models because since you're basically passing word by word to the
So
LLM,
what we do here,
the ones at the end are the most important for the model.
so what I do here, I do not even put question in the prompt. So we give it prompt with all of the
Well,
context.
you have instructions,
Ah, yeah. So
which are at the top, and then the big chunk of text that
Oh,
you
I
get
see.
from the vector.
and you're
database
saying
is
that
at the bottom.
instruction should go to the bottom.
Yeah,
I don't
exactly,
think
because those will be the closest to.
he's a smart guy. Listen to
Do
him.
you
not
think
say-
it's
don't
about
listen to
importance
him.
and not just statistics?
He will give our next talk.
Because
Yeah.
I think models
Yeah.
operate in terms of importance.
Actually, they do. And they tend to forget very quickly if you ask them
As long
few,
as they're
few
in the
questions,
window.
and then they start to lose context from the first answers.
Depends on the model. Gemini has
yeah.
huge window,
Yeah,
like millions of.
I've tested that with ChatGPT 4 or something, yeah. And basically after the third answer, because I told the model, okay, give me a short description, I mean, just give me the context, the most important part from our talk till now. And at the third answer, that it starts losing the context.
Yeah, so what's being said is neural networks, or the LLMs, start losing context at some point.
Yeah.
So it probably, so in my flow, it's perfectly reasonable to just ask one question and just for another question fully recreate the whole prompt. This way it will almost guarantee not to lose the context. And I like it, but I lose the chat ability.
And you don't create threads with the chat.
Yes, I do not. I ask a question, it gives me an answer, I'm more or less satisfied.
Why Kotlin?
I used to be a developer advocate for Kotlin and JetBrains. Not that long ago, like a year ago. Kotlin is my favorite language.
It's beautiful.
Some say it's beautiful. It's fun. Suspend, await fun, expect fun, actual fun. A lot of fun, yeah. But
Suspend the fun.
suspense, yeah, it's also there. Do we have more questions?
Have you tried funny, in the prompts? In the prompts, think like a clever agent? Have you tried funny things like critique like a drunken agent or like a confused citizen or something like that?
I'm not that good. I tried some things. I didn't even imagine asking as a drunk agent. I will try doing it, but it probably won't go to production. I should be honest with you. But maybe it should be a checkbox. If a user asks a question, they should have a checkbox. The agent should be drunk, and then we will slightly vary the prompt.
But you can increase the top P and the other things to make it hallucinate more. So
Yeah, absolutely. But it's also more expensive because we pay for all the simulation power. I do not, but my company does. When my company pays for something, it doesn't go me as my salary. So yeah. More questions? Thank you so much. You are nice.